Hello everyone. Let's start paper 5 planning analysis and evaluation of A2 chemistry, October November 2024, variance 52. Solution X is dilute hydrochloric acid. So that's the most important point, that solution X is basically dilute hydrochloric acid, and we don't know the concentration of this solution. Okay, a student uses titration with sodium carbonate to determine the concentration of solution X. By the way, hydrochloric acid is an acid, but sodium carbonate solution is basically an alkaline solution, which is why it is an acid-base reaction. Okay. The student plans to prepare 250 cm cube of 0.5 mole per dm cube aqueous sodium carbonate. Calculate the mass of sodium carbonate solid needed to make 250 cm cube of 0.5 mole per dm cube using 2 decimal place balance. So 2 decimal place balance is not much accurate as compared to the 3 decimal place balance. We have discussed that in the class, So let's find out the mass of sodium carbonate. We know the concentration, we know the volume. First, we can find the moles. Of sodium carbonate. So volume is 250.0. Concentration is 0.500. And if we divide these two values by 1000, obviously we are going to get, let me check, 250 times 0.5 divided by 1000. So we are getting 0.125 moles. Okay. We must find out the MR of sodium carbonate because we need to calculate the mass. And for that, I'll use relative atomic masses by using the periodic table. So 23 times 2 plus 12 plus 16 times 3. So I believe it's going to be 106. Yeah. Okay. So to get the mass, of sodium carbonate, we need to multiply moles by MR, which is 106. So multiply by 106. So I'll get 13.25 gram. So examiner is looking for 2 decimal place. So I'm going to write 13.25 gram. Okay. That's my answer. Next part, describe how the student should make 250 cm cube of 0.5 mole per dm cube sodium carbonate solution, starting from the mass of sodium carbonate calculated in 1, supplied in 50 cm cube of beaker. Calculate the name and size of any key apparatus to be used. Write your answer along a series of numbered steps. Okay. So first we need to measure the mass of sodium carbonate by using electronic balance. Because we need to start it from the mass of sodium carbonate. By using electronic balance. Measure 13.25 gram of solid sodium carbonate and then place it in the beaker. In 50 cm cube beaker. Add distilled water. Into this beaker. dissolve sodium carbonate solution, then transfer this solution in 250.0 cm cube volumetric flask wash the beaker with distilled water and transfer the washing into it. And transfer the washing in the flask now top of the solution or top of the volumetric flask with distilled water up to its 250 cm cube mark. And shake the flask to mix well. Okay. I hope it makes sense to you. Next part. Oh my goodness. Okay. Okay. Not an issue. The student incorrectly make up 250 cm cube of sodium carbonate and the concentration is not 0.5 mole per dm cube. The student called this solution Y. Okay. So Y is basically a solution in which the concentration is not 0.5 mole per dm cube. Now the student uses the following method to determine both the concentration of solution X and solution Y. So in order to do that, examiner is doing transfer 25 cm cube of solution Y into the conical flask using volumetric pipette. That's a very straightforward statement. And solution Y is, remember, hydrochloric acid. Okay. And we need to find out the percentage of the solution Y and few drops of methyl orange indicator. So conical flask has hydrochloric acid, and in hydrochloric acid, methyl orange shows red color before reaction because this is going to be HCl solution. Okay, so in acid, methyl orange shows red color. Now titrate the sample in the conical flask with solution X. Okay. Okay. So that indicates I think it's sodium carbonate solution. I think it's sodium carbonate solution. Hold on. We have two, sodium carbonate and hydrochloric acid. Hydrochloric acid solution X, नहीं determine तो solution Y कर दिया. So transfer 25 cm cube of solution Y into the conical flask. That's fine. So titrate कर रहे हैं हम with sodium carbonate solution. Okay. In the conical flask with solution X. Okay. Transfer the fresh 25 cm cube portion of solution Y into the second conical flask. Okay, and we need to transfer this by using volumetric pipette. So technically we are doing two different sort of titrations. First is titration with solution Y, second is titration with solution X, all right? So we are using two different burettes altogether in the experiment. Use the burette to add the volume of solution X used in step 2 to the second conical flask. Measure and record the mass of dry evaporating basin. Okay, dry evaporating basin. Okay. Dry evaporating basin. So this evaporating basin, technically sodium carbonate, when treated with hydrochloric acid, obviously salt, water, and carbon dioxide gas is given out. So we need to mass of dry evaporating basin first, transfer the content of this second conical flask into the evaporating basin, and definitely this is aqueous NaCl. Use water bath to heat the solution in the evaporating basin. Why are we using water bath instead of direct heating? So if we use direct heating, can cause, so अगर डायरेक्ट हीटिंग हम कर रहे हैं तो जाहिर सी बात है उससे स्प्लिटिंग का चांस इंक्रीज हो जाता है, इसलिए हमने वाटर बाथ यूज किया. और वाटर बाथ इसलिए भी यूज करते हैं फॉर यूनिफॉर्म हीटिंग. Evaporated and only the solid remains, and that solid is technically going to be sodium chloride. ओके, सो आपने evaporating basin में aqueous NaCl लिया, जब आपने उसको हीट किया तो जाहिर सी बात है इसमें से वाटर रिमूव हो गया और आपके पास सॉलिड सोडियम क्लोराइड बच जाए. Measure and record the mass of the evaporating basin and the solid residue. This solid residue is basically sodium chloride. Okay. 25 cm cube of solution Y is transferred using a volumetric pipette. State what the volumetric pipette should be rinsed with before carrying out step 1. देखो मैं volumetric pipette को distilled water से वॉश नहीं करूंगा, मैं इसको स्ट्रेट अवे सॉल्यूशन Y से जो है वो रिंस करूंगा. बिकॉज अगर मैं डाइल्यूट सल्फ्यूरिक मैं सबसे पहले डिस्टिल वाटर से इसको वॉश कर दूंगा और उसके बाद मैं सोल्यूशन Y ऐड करूंगा, तो वाटर अवेलेबल होगा पिपेट के अंदर, वो आपके सोल्यूशन Y की कॉन्सेंट्रेशन को चेंज कर देगा, सारे रिजल्ट को चेंज कर देगा, राइट? सो स्ट्रेट अवे वी कैन राइट हियर rinse it with solution Y. Okay. Describe how the student detects the endpoint of the titration in step 2. Obviously, when you the red color before the experiment and after the titration, obviously yellow color will observe after titration. or after reaction. So iska matlab there is a clear permanent color change is observed at the at point that is from red to yellow. Mm, permanent color change is seen that is from red to yellow. Explain why evaporating basin is not heated directly with the Bunsen burner is step 7. That was the question I've raised. ये तो question पूछा था because direct heating can cause spitting. Direct heating can cause spitting of solid. And solid कहाँ से आ रहा है? Solid यहाँ से आ रहा है. This is a solid. Okay. Suggest what the student should do to ensure all the water has evaporated from the residue before completing step 8. Obviously, you need to reheat and reweigh until a constant mass is observed. Reheat and reweigh until constant mass is observed. Okay. Next. The student burette readings taken in step 2 are shown in figure 1.1. So this is 1, 1.1, 1.2, 1.3, 1.4. So it's 1.3, 1.4, or ye line in between these two values, so it's going to be 1.35. So it's going to be 1.35. By the way, let me tell you one thing. This is the curved surface of the liquid, and this is called lower meniscus. So for colorless solution, lower meniscus is used to read the value. Okay. And what if we have colored solution in such burettes? Upper meniscus. For colored solution, upper meniscus is used. Okay. So this is the curved surface of the liquid, and the curved surface of the liquid is called meniscus. So we need to read this value. Okay. Cannot read this one, cannot read this one. This value, exact this value. So it's going to be 1.35. All right. So initial burette reading is 1.35. Final burette reading. So it's basically 14, 14.1, 14.2, 3, 4, 5, 6, 7, 8, and 9. So this value exists between 8 and 9. So it's again going to be 85, 14.85. Well, मैंने क्लास में आप लोगों को बताया है कि burette में one drop is always equals to 0.05 cm3, and that is the error in the single reading also. Okay, you can say that it's the least count of the burette. Error in single reading also called least count. Okay, So if we take out the difference between these two values, let me check. 14.85 minus 1.35 is going to be 13.5. ओके, और क्योंकि ये सब 2 डेसिमल प्लेसेस में है इसलिए 13.50. Now next is calculate the percentage error in the volume of solution X calculated in 1. I've told you that in Buret error in a single reading is 0.05. और हम सब जानते हैं कि हम 2 रीडिंग्स लेते हैं इनिशियल एंड फाइनल, विच इज वाई इस एरर को हम मल्टीप्लाई करेंगे 2 से डिवाइडेड बाय द वॉल्यूम, और वॉल्यूम हम क्या यूज करें 13.50 into 100. So let me check. This 0.1 divided by 13.5 divided into 100 into 100. So I'm getting what? 0.7407. 0.7407%. So it's going to be 0.741%. Okay, I hope it makes sense to you. A student, second student repeats the experiment in B using solution X, 25 solution of cm cube of solution Y. The results are shown in the table. The reaction that takes place in the titration is this. Okay, using the table 1.2 to calculate the following. Okay, the amount in moles of sodium chloride. Okay, this is the mass of dry evaporating basin and mass of evaporating basin and solid residue. So if I'll subtract these two values, I'll get the mass of NaCl. Mass of NaCl so mass of basin plus solid residue minus mass of dry basin. So technically it is 45.69 minus 44.52. So I'll get how much? 45.69 minus 44.52. So I'll get how much? 1.17 gram. This is the first step. Examiner is looking for the amount in moles of sodium chloride. So, my goodness, I'm running out of space. It's all right. In order to calculate the mass of NaCl, we need to multiply the moles. Sorry. Oh my goodness. Oh my goodness. We need to find out the moles of NaCl. So we need mass, which is 1.17 divided by the MR of sodium chloride. So chlorine is 35.5 plus 23 is going to be 58.5. So 58.5 is basically the MR of sodium chloride. So answer is going to be 1.17 divided by this. So it's 0.02 moles. Okay. Now the next part is concentration of solution X and the concentration of solution Y. Okay. So between HCl and NaCl, we have same ratio. So अगर हमारे पास 0.02 moles इसके हैं तो moles of HCl भी हमारे पास same हो जाएंगे, which is 0.02 moles. And ये हमने कितने वॉल्यूम में कैलकुलेट किया है? ये हमने टेक्निकली 25 cm क्यूब वॉल्यूम में कैलकुलेट किया है. सो होल्ड ऑन इनटू ये 13.5 में कैलकुलेट, एक मिनट, 0.02 जी. सो ये जो, नहीं ये एक मिनट, ये हम डिस्कशन कर रहे हैं सोल्यूशन एक्स की, ठीक है. सोल्यूशन एक्स. सो 13 पॉइंट, कितनी कैलकुलेशन की थी हमने एक्स की यहाँ पर, 13.50. 13.50 contain 0.02 moles. So अगर हमारे पास 1000 cm cube है, concentration is going to be how much? 1.481 mole per dm cube. So this is the concentration of solution X, which is 1.48. Okay. Hold on. 14.85 minus 1.35. 13.5. It's fine. ठीक है. Okay. Oh, my bad, my bad, my bad, my bad, my bad. ये बहुत इसलिए मिस्टेक थी मेरे एंड से, होनी नहीं चाहिए थी. I didn't read the question properly. This is 13.50 and that was the volume examiner has given us, 13.35. My God, 13.35. My goodness. So guys, you have to be very, very careful. 13.35 cm cube contain 0.02 moles. So if you have 1000 cm cube, oh my goodness, 0.02 into 1000 divided by 13.35, 1.498 mole per dm cube. So concentration is going to be 1.498, so it's going to be 1.50 mole per dm cube. Okay, that's solution X. Let's talk about solution Y. And obviously solution Y के लिए we need to compare sodium carbonate and NaCl. Now it is 1 mole, it is 2 mole according to the equation. अगर आपने 0.02 moles determine किए थे तो moles of sodium chloride कितने हो जाएंगे? 0.02 divided by 2, it's going to be 0.01 mole. Mole of sodium carbonate is basically 0.01 mole. In the next step, how much amount we have? 25 cm cube solution Y. Okay, so 25 cm cube contain 0.01 mole. So if we have 1000 cm cube, so concentration is going to be how much? जगह कम दिए, कैलकुलेशन बहुत है. 1000 divided by 25, so it's going to be 0.4. क्योंकि यहाँ 2 डेसिमल प्लेस है तो हम यहाँ पर भी 2 डेसिमल प्लेस तक बात करेंगे. 0.4 3 सिग्निफिकेंट तो यहाँ पर लिख दीजिए 0.400. ठीक है, यहाँ 3 सिग्निफिकेंट फिगर्स तो यहाँ भी 3 सिग्निफिकेंट फिगर्स. 0.400. ओके, माय गुडनेस, दैट्स टफ. Next is state what happens to the value obtained for the concentration of solution Y if not all the water is evaporated in step 7. Solution Y के साथ क्या होगा? अच्छा, solution Y के साथ अगर नहीं होगा तो फिर क्या होगा? वाटर अगर रहेगा, अगर वाटर रहेगा तो जाहिर सी बात है ये जो हम मास निकाल रहे हैं सोडियम क्लोराइड का ये ज्यादा आएगा. जब मास ज्यादा आएगा तो मोल्स भी क्या आएंगे? ज्यादा. अब जब मोल्स यहाँ पर ज्यादा होंगे तो जाहिर सी बात है ये वैल्यू और क्या हो जाएगी? कम. ठीक है ना? सो ऑब्वियसली जब वैल्यू कम हो जाएगी तो कॉन्सेंट्रेशन ज्यादा हो जाएगी, राइट? बिकॉज कॉन्सेंट्रेशन किसकी इक्वल होती है? नंबर ऑफ मोल्स पर यूनिट वॉल्यूम. सो जब मास ज्यादा, मोल ज्यादा, कंसेंट्रेशन भी ज्यादा. सही है, कुछ इस तरह से देख लीजिए. सो if not all the water is evaporated, then mass of residue, that is mass of sodium chloride, becomes higher. Number of moles also increases. तो फर्स्ट स्टेप मैंने ये लिखा है कि मास ऑफ NaCl residue increases, so moles equals to mass upon mR होता है. तो अगर मास इंक्रीज हो रहा है तो मोल्स भी क्या होंगे? इंक्रीजेस. दूसरा, कॉन्सेंट्रेशन किसकी इक्वल होती है? मोल्स पर यूनिट वॉल्यूम. सो अगर मोल्स ज्यादा है तो कॉन्सेंट्रेशन भी क्या हो जाएगी? ज्यादा, राइट? तो कलर चेंज कर लेते हैं. नंबर ऑफ मोल्स इंक्रीजेस, सो दिस इंक्रीजेस the concentration. Concentration of solution Y. Okay. All right, so that's the end of this question. Oh my goodness. Kind of little bit easy. Question number 2. A group of students uses the following method to investigate the change in mass that takes place. Change in mass निकालना है. So change in mass निकालने के लिए examiner is using metal M combined with sulfur to form metal sulfide. ये मेटल एम ग्रुप 1 का भी हो सकता है, ये मेटल एम ग्रुप 2 का भी हो सकता है और ये मेटल एम ट्रांजिशन एलिमेंट का भी हो सकता है. ठीक है, सो एग्जामिनर डिडंट गिव एनी स्पेसिफिक इंफॉर्मेशन रिगार्डिंग दिस. चलो ठीक है, अगर एग्जामिनर ने नहीं दी तो कोई बात नहीं, हम पढ़ लेते हैं उसको. Weigh a clean crucible and lid using a balance. Record the mass. Okay. All right. I can record the mass. This is the first step. Then place a coiled length of metal wire into the crucible and weigh the crucible lid and wire. Okay. So first of all, mass of empty crucible plus lid in gram. Okay. Then mass of crucible plus lead plus metal slash gram. Then after that, cover the metal wire in the crucible with a large quantity of powdered sulfur and replace the lid. Okay. Heat the crucible in a fume hood. Why are we using fume hood? Because powdered sulfur has a large surface area. So when sulfur is heated in the presence of air, obviously air contains oxygen, it will turn to sulfur dioxide. So sulfur dioxide is basically toxic gas, causes lungs inflammation and lungs irritation, which is why we need to perform this experiment in a fume cupboard or fume hood. All right. And the crucible glows red. Continue heating strongly until no more sulfur can be seen. So might be the equation going to be like this: metal and sulfur are reacting together through heat and converting into metal sulfide. So that's the whole equation. Okay, allow the apparatus to cool and weigh the crucible. Why are we allowing the apparatus to cool? So that वो रूम टेम्परेचर अचीव करे, क्योंकि रूम टेम्परेचर अचीव करने के बाद हम जब वे करेंगे क्रूसिबल को तो जाहिर सी बात है वो एक्यूरेट वेट आएगा हमारे पास. ठीक है. To maintain the temperature or to maintain it to RTP to get the accurate value. Okay. So this is going to be the next mass of crucible plus lead plus residue slash gram. Okay. And that's the diagram. And in the diagram, what's missing? Obviously, ये crucible हवा में तो नहीं हो सकती. चाहिए if it is a tripod stand. So obviously wire gauze needs to be here जिसके ऊपर हम ये crucible रखेंगे. So there has to be a wire gauze there. Okay. Hmm. ठीक है. Identify the missing piece of apparatus used to support the crucible during heating. So obviously tripod तो है लेकिन tripod stand नहीं है and wire gauze नहीं है. Wire gauze and wire gauze is fine. That's it. ठीक है. Suggest why the student heat their crucible in a fume hood in step 4, because during heating, poisonous sulfur dioxide gas is given off, which causes lungs irritation. Suggest why a large quantity of powdered sulfur is used in step 3 to make sure all the metal M has been used up during the reaction. Okay. That is the statement, large quantity. So what we can write here, to ensure complete reaction with sulfur. Okay. Next, oh my goodness, 5 students each uses a different mass of M. The results are shown in the table 2.1. Complete table 2.1 by inserting values of the mass of M and the mass of sulfur, which reacts for each student. Okay. So this is, oh, ये मैं वहां बना रहा था, exact यहाँ पर examiner ने बना के दिया है. So mass of M निकालना है. This is mass of crucible, lead and M. This is mass of crucible and lead. So if I'll subtract these two values, I'll get mass of M. So let's suppose this is A, let's suppose this is B, let's suppose this is C. So in order to get mass of M, let's subtract B minus A slash gram, okay? 35.58 minus 34.15. 35.58 minus 34.15. 1.43. Then subtract these two values, 39.42 minus 38.28. So it's going to be 1.14. I'll subtract these two values, 36.54 minus 35.68 is going to be 0.86. Let's subtract these two values, 34.27 minus 33.7 is going to be 0.57. Then subtract these two values, 37.13 minus 36.84. It's 0.29. ओके आप नोट करें, लेकिन ये वैल्यूज कम हो रही हैं, लेकिन ये वैल्यूज सबसे ज्यादा है ना? ओके, ये वैल्यूज सबसे ज्यादा है इन तम में. So this is going to be the anomalous point among these. Mass of sulfur अगर आपने डिटरमाइन करना हो, which reacts, okay. Mass of sulfur after heating, okay. ये जो residue है आपके पास, this residue is basically metal sulfide, okay. So in order to calculate the mass of sulfur, so if I'll subtract these two values, I'll get the mass of sulfur, because this is mass of crucible, lead and M. This is mass of crucible, lead and residue, and this residue contains metal sulfide. I mean metal and sulfur both. So if I'll subtract these two values, I'll get mass of sulfur, which reacts with metal M. So it's going to be C minus B slash gram. So let me check, 36.04 minus 35.58. So it's going to be 0.46. Then we have 0.28. Then 0.20, 0.15, and then 0.06. Identify the independent variable in this experiment. Independent variable हम किसे कहते हैं? What we change. And independent variable has to be on the x-axis, right? So x-axis पे mass of m है, इसका मतलब mass of m has to be on the x-axis, which is the independent variable. और हम change किसको कर रहे हैं? हम देखें यहाँ पर हमने बताया भी आपको different masses of m. That means we are changing the masses of m. इसका मतलब it's going to be the independent variable. We are taking different masses. Okay. Oh my goodness. Oh my goodness. Plot करना graph. Plot a graph on the grid in figure 2.2 to show the relationship between mass of sulfur, which reacts, and mass of M. Use a cross X to plot each data point and draw a line of best fit, which includes the origin. Okay, origin को भी include करना है. Line of best fit है. Okay. What you can do is let me copy this thing. ताकि हमें ग्राफ बनाने में आसानी हो. Oh, oh yes. Okay. So हम यहाँ रखते हैं इसको. और अब प्लॉट करते हैं. So ये है हमारे पास M, ये है हमारे पास सल्फर. So 0.46. So 0.46. So this is going to be 0.46. And on that value, I have 1.43. One point four three. So 1.43 is technically going to be here. So point is going to be like this. This is the point. Okay. Since my eyesight is really, really weak, so I can't read the points properly, which is why I'm writing the lines, drawing the lines here. This is my first point. Okay, this is my first point. So I'm done with this point. Next is 0.28, 0.28, 0.28. So 0.28 is going to be like this. 26, 27, 28. This is 0.28. And we have no. And we have 1.14. So 1.14. So 1.14 is technically, this is 1.1. 1.14 has to be here, somewhat here. 1.1 here. Okay. मैं जितना कोशिश कर सकता हूँ एक्यूरेट बनाने की तो मैं कर रहा हूँ, लेकिन आप लोग भी कोशिश कीजिएगा. This is a point. So I'm done with this point also. Now the next is 0.20 and 0.86. So 0.20, this is 0.20, and then 0.86. This is 0.8, and this is 0.1, 0.9, 0.86, 2, 4, 6, 8, somewhere around here. ये कुछ यहाँ पर बनेगा. Somewhere here. Oh my goodness, that's very tough. Very tough for me to adjust this. This is going to be here. मुझे टफ इसलिए लग रहा है क्योंकि मेरी आई सेट बहुत वीक है. पॉइंट्स जो है वो ओवरलैप होते हैं मुझे. आई एम ट्राइंग कि एक्यूरेट बने ताकि हमें आगे कैलकुलेशन में कोई प्रॉब्लम ना हो. थोड़ा सा टाइम लगेगा लेकिन चीजें ठीक होंगी बिल्कुल. सो आई एम डन विद दिस पॉइंट ऑल्सो. नेक्स्ट इज 0.15. This is 0.15. Oh, okay. And 0.15, 0.57. 0.5, this is 0.5. This is 0.5. This is 0.57. So somewhere around, oh, sorry, this is 0.7. This is 0.5. And this is going to be 0.57, somewhere around here. Okay. Oh my goodness. I'm done with this point also. Next is 0.06 and 0.29. 0.06. This is 0.06. This is 0.06. And how much? 0.29. So this is 0.2. This is 0.3. This is 0.29, somewhere around here. So this is the point. I hope हमने सही बनाया हो. I hope. मैंने ठीक किया हो. Oh no, ये नहीं है. ये होगा 0.6. 0.6. 0.06 ये होगा यार. This is 0.06, 0.07, 0.08, 0.09, this is 0.1. So it has to be here. Here. Hold on. It has to be here. Okay. So, my goodness, ये तो points line of best fit पे मुश्किल से ही आएंगे अगर मैं origin लूंगा तो. Let's check. ये तो आ ही नहीं रहे points. ये भी नहीं आ रहा point. ये तो origin से कह रहे हैं तो origin से तो मिलेंगे ही. I don't know. काम तो मैंने बिल्कुल सही किया हुआ. My goodness, मैं चेक करूंगा एक मरतबा और अपने पॉइंट्स कि गलती तो नहीं हुई है कहीं. ये सही है, आई थिंक सो. ये सही है हमारा. या इट्स फाइन. इट्स फाइन. इसके अलावा कुछ और हो नहीं सकता. ठीक है. तो जो है वो आपके सामने. एंड ऑब्वियसली दिस इज गोइंग टू बी द मोस्ट एनॉमलस पॉइंट. और मैंने कहा था आपको कि ये वैल्यू सबसे ज्यादा है इन तमाम वैल्यूज से. सो दिस इज गोइंग टू बी द एनॉमलस. तो आप नोट करें ये एनॉमलस पॉइंट ही आया है क्योंकि ये इस लाइन ऑफ रेस्ट से सबसे ज्यादा दूर है. ठीक है. ओके. लेट्स मूव ऑन टू द नेक्स्ट पेज. Circle on the point the graph you consider to be the most anomalous. The most anomalous point is going to be this one. Okay. Assume no error was made in the measurement. Suggest one reason why this anomaly may have occurred during this experiment. जाहिर सी बात है, मास ऑफ सल्फर जो है वो ज्यादा आया है आपके पास. तो अगर मास ऑफ सल्फर आपके पास ज्यादा आया है तो यकीनन उसके पीछे रीजन यही होगी कि सल्फर जो है वो प्रॉपर तरीके से रिएक्शन नहीं कर रहा है जिसकी वजह से उसका मास ज्यादा आया है. राइट. ठीक है ना. ये मास ऑफ सल्फर है, ये ज्यादा आ रहा है. सो मास ऑफ सल्फर अगर ज्यादा आ रहा है तो इसका मतलब उसने रिएक्शन प्रॉपर तरीके से नहीं किया. हो सकता है हमने हीटिंग जो है वो इतनी स्ट्रांग नहीं की हो कि सल्फर जो है वो रिएक्शन कर चुका हो। सो हो सकता है हमसे हीटिंग प्रॉपर तरीके से नहीं है, जिसकी वजह से सल्फर ने जो है वो रिएक्शन तरीके से नहीं किया और कुछ ना कुछ सल्फर जो है वो अनरिएक्टेड फॉर्म में रह गया। ठीक है, सो हम ये लिख सकते हैं बात। सो हम यहाँ लिख सकते हैं कि हीटिंग should not be done properly, so not all the sulfur has been removed or reacted during the reaction. During the reaction. Determine the gradient of your line of best fit. Okay, state the coordinates of both points you used in your calculation. There must be selected from your line of best fit. So जो भी points ले रहे हैं वो line of best fit के होने चाहिए. Give your gradient to 3 significant figures. Okay. So हम इसको कर लेते हैं, कोई इशू नहीं है. So basically हम क्या कर सकते हैं, हम 3 पॉइंट्स लेना चाहते हैं तो हम सो बेटा मैं एक पॉइंट ये ले लेता हूँ. सही है, और ये हो जाएगा आपके पास 0.05 एंड 0.2. ठीक, और एक पॉइंट मैं ये ले लेता हूँ और ये हो जाएगा 0.15 एंड 0.3. सॉरी, तो ये हो जाएगा आपके पास, ये हो जाएगा 0.05, 0.2 एंड देन फिर आपके पास नेक्स्ट क्या हो जाएगा 0.15, 0.6. सही है, ग्रेडियंट निकालने के लिए कह रहे हैं. सो ग्रेडियंट हमेशा होता है डेल्टा वाई ओवर डेल्टा एक्स. वैल्यू हमें पता है डेल्टा वाई की और डेल्टा एक्स की, तो प्लग इन करते हैं वैल्यूज को. ये हो जाएगा 0.15 माइनस 0.05 डिवाइडेड बाय 0.6 माइनस 0.2. सो ये हमारे पास आंसर क्या आएगा, 0.15 माइनस 0.05. फॉर्मूला 0.15 minus 0.05 is going to be 0.1 divided by 0.6 minus 0.2 is going to be 0.4. So 0.1 divided by answer is going to be 0.25. So gradient is going to be 0.25. Okay. Use your line of best fit in figure 2.2 to determine if the results obtained by the solution are reliable. Explain your answer. Reliability जो है वो आई डोंट थिंक सो कि इतनी ज्यादा कोई मुझे खास नजर आ रही, बिकॉज ज्यादातर पॉइंट जो है वो लाइन ऑफ बेस्ट फिट के ऊपर एग्जिस्ट नहीं करता है. राइट, सही है ना, सिर्फ एक पॉइंट लाइन ऑफ बेस्ट फिट के ऊपर है आउट ऑफ 1 2 3 4 and 5. तो मेरे ख्याल से हम लिखेंगे not reliable at all since most of the points are not lie on the line of best fit, which is why whew, which is why results obtained are not reliable. Okay. God, that's a lengthy question. Another student suggests that the metal M used in the experiment is strontium. Strontium uh, as a symbol of SR, which forms strontium sulfide when heated with sulfur. Deduce the gradient of the line of best fit for the graph of mass of sulfur which reacts with against magnesium. Okay. So gradient is basically what? Delta y upon delta x. इस डेल्टा y के ऊपर मास ऑफ सल्फर है और डेल्टा x के ऊपर मास ऑफ स्ट्रोंशियम है. So mass of sulfur is not given, mass of strontium is not given, which means we need to consider relative atomic masses of both the elements. And for that, let's move on to the periodic table. Periodic table means strontium is found in group 2 of the periodic table. Strontium is 87.6 and sulfur is basically 32.1. 32.1 and 87.6. Okay. So it's basically 32.1 divided by 87.6. So it's going to be how much? 32.1 divided by 87.6 is going to be 0.3664. 0.3664. So it's going to be 0.366. Okay. Use your answer to 1 to explain if the results of the experiment support the student suggestion. Obviously, ये gradient आया 0.366 और ये जो gradient मेरे पास आया 0.25. Since both the gradients are different, which means it is not strontium, and it's never support the student suggestion. Okay. Since both the values of the gradient, both the values of gradient are different, so this doesn't support student suggestion. Student suggestion. Okay. I hope it makes sense to you. That's the end of this paper.